Isaac, and in this video we'll explore the powerful application of artificial intelligence in the field of robotics. The merger of these two fields is one of the most exciting developments in modern technology. For decades, robots were just automated machines programmed to perform one specific repetitive task, like welding a car door. They were powerful but dumb, limited to an exact script they were given. But AI is fundamentally changing that. The importance of AI in robotics is that it provides the brain for the robot's body. It's the difference between simple automation and true autonomy. This synergy creates a machine that is more than a sum of its parts. Instead of just allowing a script, an AI powered robot can perceive its environment, make intelligent decisions based on that perception, and learn from its experiences. This is the key to unlocking the true potential of robotics, moving them from the predictable, structured cages of factories into our complex, dynamic, and unpredictable daily lives. Now we're going to talk about the three pillars of robotic intelligence, analyzing AI core's contribution to capability. First, we have perception. This is a robot's ability to see, hear, and understand its surroundings. Instead of just a simple sensor, AI, especially computer vision, often powered by deep learning models called convolutional neural networks or CNNs, allow a robot to process camera data. It can identify and classify objects, track people, and read text, but perception is more than just vision. AI is used for sensor fusion, a critical concept where the system combines data from light-based data, radar, cameras, and ultrasonic sensors. This creates a single rich 3D model of the world that is more accurate and robust than any single sensor could provide, offering redundancy that is vital for safety. Second, we have decision making. Once a robot perceives the world, it has to decide what to do. This is where planning and control algorithms come in. This isn't a pre-programmed if-then statement. It's a dynamic process. AI pathfinding algorithms like A-star calculate the most efficient route to a goal. If a self-driving car's perception system sees a pedestrian, its decision-making AI must instantly calculate the risk, model the pedestrian's likely path, check all alternative actions, and decide to brake all within milliseconds. It is a constant loop of probabilistic reasoning. Finally, and most importantly, it's autonomous learning. This is a shift through machine learning. Using a technique like reinforcement learning, a robot can learn a complex task by trial and error, in a simulation or the real world. The AI is given a reward function, a goal, like successfully pick up the cup. It tries millions of motions receiving a digital reward for actions that get it closer to the goal and a penalty for failures. Over time, it optimizes its own strategy to maximize the reward. This is how AI can teach a robotic arm to pick up an object it has never seen before, or how a humanoid robot learn the complex physics of balancing as it walks. Now we have AI impacts across robotic subfields. AI impact isn't uniform, it's having a massive effect on a specific subfield. In industrial robotics, AI is creating the smart factory or Industry 4.0. We now have cobots or collaborative robots. These are not in cages. They use AI-powered vision and force torque sensors to detect the human's presence. They can slow down when a person is near and stop completely with touch, making them safe partners. Also, AI is also used for quality control, where a high-speed camera uses AI vision to spot microscopic defects on a production line far more accurately than a human eye. In mobile robotics, AI is all about autonomous navigation. The key technology here is often the SLAM, simultaneous localization and mapping. This is an AI-powered technique where a robot builds a map of an unknown environment while simultaneously keeping track of its own position within that map. This is what allows aerial drones to inspect power lines and find the best route, or last-mile delivery robots to navigate city sidewalks and avoid pedestrians. This all leads to autonomous robots, which are the full integration of these concepts. The most famous example is the autonomous vehicle, or self-driving car. It is a mobile industrial-grade robot that must perceive, decide, and act with complete autonomy. AI is what allows the system to aim for, say, levels 8 and 5. Full autonomy where the machine can handle all driving tasks in virtually all conditions without any human intervention. Now we have AI in action, real-world examples. Now let's take a few examples to current project where AI is playing a crucial role. First of all, we have the great example what is Waymo, which operates a fully autonomous ride-hailing service in several cities. Their AI system, the Waymo driver, is a fantastic case study. It doesn't just see a shape in the road, its perception AI identifies it as a pedestrian. But it goes further. Decision-making AI, trained on billions of miles of simulation, predicts the future behavior of all agents in the scene. That pedestrian, the car waiting at the intersection, the cyclist up ahead, it predicts their likely next moves, allowing it to drive more defensively and safely than a human. In logistics, we have the Amazon Robotics that uses AI to manage an entire fleet of thousands of robots in warehouses. The AI isn't just one robot, it's a hive mind or fleet management system. This is a massive AI planning and optimization problem. The central AI optimizes the entire system, deciding in real time which of the thousands of robots would fetch which item to fulfill customer orders with maximum efficiency. And finally, a project formed Richard Labs like Boston Dynamics. Their Atlas robot is a powerful example of AI for advanced control. Atlas doesn't follow a preset path. It uses vision to identify the terrain, and its AI control system, which uses techniques like model predictive control, it's constantly simulating the physics of its own body and the world. It makes thousands of micro adjustments per second to maintain balance, run, jump, and even manipulate objects, demonstrating a mastery of dynamic real-world interaction. Conclusion: artificial intelligence is the single most important factor driving the evolution of robotics. It elevates robots from being simple, repetitive tools to becoming adaptive, intelligent partners. AI is a software brain that finally allows the robotic body to leave the structured, predictable factory and enter the messy, unstructured, and dynamic human world. As for the future of AI in robotics, I believe we are moving toward even deeper integration. We will see robots that move beyond just learning from experience and begin to use common sense reasoning. This means instead of just learning how to do a task, they will start to understand why they are doing it. We'll also see more learning by demonstration or imitation learning, where a human can simply show a robot a task like how to fold a tower or assemble a part, and the robot's AI will learn that to mimic and then perfect that action. Finally, a key future trend will be explainable AI or XAI. As robots make more high-stake decisions in medicine or driving, it will be crucial for us to understand why they are making a certain choice. Chai will be essential for building trust, ensuring safety, and debugging these complex systems as they become a bigger part of our lives, creating a future where robots and humans can collaborate safely and efficiently. Thanks for watching, and I'll see you next time.